Here we're going to go through reaction number 5 for organic chemistry reaction mechanisms. Here we're going to look at an alkene reacting with a halogen. And this is something that does not require a catalyst, and that's a big deal because we can use this type of reaction then as a qualitative measure of whether or not we have units of unsaturation. So this does not just work for an alkene, this will work for an alkyne, or if we have a longer molecule, if we have multiple alkenes, double bonded carbons, or if we have multiple triple bonds, any unit of unsaturation we can detect using bromine. Now bromine, of course, is a liquid, and bromine is orange in color. So our test for that is that if we add bromine and there is a double bond, bromine will react with that double bond, and then that orange color will disappear. Whereas if there is not any double bonds or triple bonds, that bromine will persist and will maintain an orange color. Okay. So the way this reaction goes is like this. We have a nucleophilic set of carbons here, and we have a halogen. So this needs to be kind of positive in charge, so to speak. We need this to be electrophilic. So what's going to happen is that this is actually going to form a bond with one of the bromines. And then this bond is going to break, and the electrons are going to stay with the bromide that's produced. Now, this forms an interesting intermediate. What's going to happen is it's going to form an intermediate that looks like this, where it's got your original carbon, and then it's got the bromine, not just attached to one, but actually in a cyclic group here with the other two carbons. And so we have this, and we have our bromide that's still present. Okay. And so we have our bromide, and then this, of course, would have a positive charge on it. So we form this kind of ringed intermediate that's incredibly unstable, but that allows us to work within the game of electrophile and nucleophile properly. Okay, it's challenging to perhaps have a halogen act as an electrophile, and this is how we get it to work. Not how we get it to work, but it's how it works. So at this point, we have a really unstable ring right here with positive charge. So we have really a lot of looking for electrons, and of course we have this nearby. So what's going to happen is this is going to come in, and this is going to either bond with one of these carbons or this one. And which one kind of depends on the bond lengths here. Now, this carbon is really a little bit more unstable than this one because this one has some electron density to draw from here. So what likely will happen is actually this bond length is going to increase and this one's going to decrease as the bromine pulls closer to this to bring in a little more electron density. So this is actually more likely to hit here. I don't think it's 100% more likely, but you would see more of this occurring. And then at that point, we will end up with a bromine attached here. And then we'll have another bromine attached up here. Now the end result of this reaction, and we can write out without the mechanism and look at really simply that what we have happening here is we have 1, 2, 3, 4. We have 4 carbons. We have C4H8 plus Br2 yields C4H8 Br2. So a simple addition reaction, we're just combining the two. The mechanism actually shows us some incredible detail into some of the stereochemistry that might form. For example, this carbon will be chiral in a stereocenter. But we can also look at this again from a qualitative perspective of we have this orange colored liquid. If we add it to something and we're checking to see if there's the presence of double bonds or triple bonds, we'll see that orange color disappear to indicate that there are double or triple bonds, and it will persist if there's only single bonds. So this is actually a really useful reaction in the realm of chemistry if you're trying to test like an oil or some kind of food substance to see how much unsaturation there is. So here I'm going to go ahead and show you the chemical reaction. So what I have is I have two different liquids here. The first one I'm going to pour into this test tube here. And this one. Okay. And then the second liquid I'm going to pour into the second and fourth ones. And one of these is going to have double bonds present, the other one's not. And so to test which one is which, what I'm going to do is I'm going to add some bromine to it. So I have prepared some bromine water, You can see the orange color here, of course. So the key here is that when I add that bromine to these different substances, if there are double bonds present, it's going to react with those double bonds, and that's going to remove that color of orange. So I'm going to put this into our larger test tube here, and this into our larger test tube here. And so you can see the presence of the orange color in both, but then what I'm going to do is I'm going to take those and I'm going to shake them. And when I do that, you're going to see this one here. That orange color is now gone. Whereas this one, no matter what I do to shake this, that orange color is going to persist. So you can see now, this one is now different, having reacted with that bromine, than the original point. And what's happened there is that this has reacted with the bromine because of the presence of double or triple bonds. This one is only single bonds, and so we do not see any reaction with the bromine. In order to get these react, we would need to use ultraviolet light or something along those lines to get that to work. So this one here, we can see that it clearly has reacted with the bromine. This one we still have the orange color persisting, so the disappearance of the orange of that bromine is indicating the presence of a double or triple bond. In this case, we can see the comparison between the two substances before and after the bromine addition is quite different. And then here we still have the same layer. Here at an angle, so if I can kind of pull this out right, you would actually see a clear layer, and then the orange layer of the bromine is actually on the bottom there. Okay.